right, so what we're going to talk about is another method for solving quadratic equations, and this is going to be using square roots, okay? So we're going to go over a couple different things in this video, and what I would like to start with is a quick little review of simplifying square roots, okay, just to make sure that we remember how to work through those concepts. And so what I'm going to do here is just a quick little review. I'm going to put up some problems, and I'm going to give you the freedom to follow along with me here, okay, and work through these. Or if you would like, you can go ahead and hit the pause key and you can work through these problems independently and then fast forward and see if you got the answer correct, okay? So those are our three little review problems that we're going to start with. Okay, if you're deciding to stay with me, let's go ahead and work through these. So in this case, okay, since 1 and 4 aren't divisible, I'm going to go ahead and use that property where I'm allowed to split the square root and square root the numerator and denominator independently. And so we end up with square root of 1 is 1, and the square root of 4 is 2. And so this just simplifies to be 1/2. Now, this is a little different, okay? So 4 and 5, again, since they're not divisible, let's go ahead and split that radical. And in this case, we get 2 divided by the square root of 5. And when we work through these problems today, we're not going to be leaving our answers with the radical in the denominator. So let's remember what we need to do to rationalize this. And what we're going to do is we're going to multiply the numerator and denominator by square root of 5. What we're really doing again is we're multiplying by 1. So we're going to change the way the problem looks, but not its value. The numerator is going to be 2 square root of 5, and square root of 5 times square root of 5 is 5. Okay, remembering again that this is the square root of 25, which then simplifies to be 5. And this would be considered a more simplified form. Now finally, we have these problems where we have this binomial in the denominator, and this time multiplying by square root of 3 is not going to rationalize the denominator. So what we do in this case is we multiply by its conjugate. And the conjugate is those plus or minus pairs where we change the middle sign. And now we're just going to do a little bit of distributing, and here's what it's going to look like. So in the numerator, I'm just going to distribute the 5 and get 5 plus 5 square root of 3. Now the denominator, we're going to double distribute. We're going to take 1 times 1 and 1 times square root of 3, and then take 1 times negative square root of 3, and negative square root of 3 times the square root of 3 is going to be minus 3. Now let me give you a heads up with this. In the denominator, when you multiply conjugates, one will always be negative and one will always be positive. Your last term right here will always be a minus, okay? That tends to be something that students mess up on, is they get the wrong sign right there. So the final simplified form is going to be 5 plus 5 square root of 3. We see here that what happens is the square roots cancel, and we're left with 1 minus 3, which is negative 2. Now, I'm not terribly concerned if you leave your answer with a negative 2 in the denominator, but I am going to tell you that oftentimes what you'll see on an answer key is they'll simplify this negative by dividing everything by negative 1, okay? And so what will happen is this will be a negative 5 and a negative 5 square root of 3, which then makes the denominator a positive 2. And so again, just with those denominators, it's not totally considered simplified to have a square root in the denominator or to have a negative in the denominator. If there's a negative in the denominator, often that means we need to divide every term by negative 1. All right, so let's go ahead and let's start with this solving method. But before we get into it, there's one quick thing that we need to talk about, okay? Since we were just simplifying radicals. When simplifying square roots, okay, when simplifying radicals, we use the function y equals the square root of x. Now, I don't know that we've necessarily ever talked about what y equals the square root of x looks like, so I'm going to go into my y equals. You can just watch. You don't have to go grab your calculator right now if you don't want to. And I'm going to put this in, and this is what the graph looks like. Okay, and what you notice is that all the y values, all the outputs are all positive. And so I'm going to come over here. Let's just make a quick little sketch, because since we've never really talked about this function before, but this is what the function looks like, right? And all the y values are positive. So that's why when we say the square root of 16, we just say that it equals 4. When we take the square root of 25, we just say that it equals 5. okay? And we just have defined square roots to equal positive numbers. However, when we solve quadratic equations, okay, and this solving method is going to involve square roots. When we solve quadratic equations, okay, we use the function y equals x squared, which is a different function, right? This is a parabola. So we have two different things we're looking at when we solve a quadratic as compared to when we just simplify a radical. And so let's say, for instance, we have this equation, x squared minus 16 is equal to 0. And so what this parabola does is this is a parabola that opens up, that is shifted down 16 units. And it's going to go like this. And like we did before, we would graph the left side in y1, and we would graph y2 is equal to 0. And if you recall from before, what we're identifying is the x-intercepts, okay? Well, the x-intercepts would be positive 4, and the x-intercepts would be negative 4. And in this case, there's two different answers, okay? So when we solve this using square roots, what we would do algebraically is we would add the 16 and say x squared equals 16. When we square root both sides, right, which is what cancels out the squared, it's x equals, and what we would say then is it's going to be a negative 4 and a 4, right? Because when we plug it back in, if we take negative 4 squared, it makes the equation true. And when we plug in positive 4, it makes the equation true. And so often what you'll see is we write x equals plus or minus 4. Well, then what happens is now we get in the habit of writing plus or minus, and then you're asked to simplify a simple radical, and we want to say plus or minus 6, okay? And this is kind of my point, is when we just simplify a radical, we're using this function right here. When we simplify radicals, where we just define the square root of a number as being a positive. But when we're solving a quadratic equation, we are thinking about a parabola that crosses the x-axis twice, and that's why we're going to use the plus or minus. All right, I hope that made a little bit of sense, because that's always something a little bit confusing that comes up after we start solving using square roots. All right, example 1. Example 1 is going to be in the form of ax squared plus c is equal to 0. So the first case that we can solve using square roots is when it's written in standard form, right? Recall that, let me do this over here. Recall that standard form looks like this. And so when you have standard form, but you don't have a middle b term, that's when a good problem that we're going to use square roots for. All right, so here's the problem. Let's suppose we have 3 times x squared minus 7 is equal to 15. Now I know that this problem doesn't quite look like what I have in red, so maybe we do a little bit of work first. I'm going to distribute the 3, and you can see here that we don't have that middle x term. And so what I'm going to do is I'm going to isolate the x squared, and we're going to get 3x squared equals 36. Divide both sides by 3. Get the x squared by itself before you cancel out the squared with the square root. And that's where we square root both sides, okay? The square and the square root cancel, and we get x equals. Now, the solution is going to be plus or minus the square root of 12. Again, we're thinking about a parabola that crosses the x-axis, and it's going to cross twice. Now, we're going to simplify our final answer. Whether the directions say it or not, from here on out, it is assumed. And so I'm going to split this into square root of 4, square root of 3, and then I can cross out the square root of 4 and make it a 2. So our final answer is going to be plus or minus 2 square root of 3. And this right here is what we call the exact solutions, okay? I'm going to go into the calculator, and I'm going to type in 2 square root of 3, right? So the approximate solution would be 3.464. 464, okay? And then obviously negative 2 square root of 3. And so this is what the calculator would have told us if we would have solved it graphically, is it would give us the approximate solution. But one benefit of solving using square roots is that we can get the exact solution, which in many cases is actually easier to use than this approximate solution, which is a number that is irrational and goes on forever. And so that's kind of the difference between the two. We're going to write our answers as exact answers written in reduced radical form. All right, example 2. So the next form that we can solve using square roots is when it's written in vertex form, okay? If you can recall, that vertex form looks like a times x minus a number squared, and then maybe it's like plus or minus a number right here. And so what you notice is you have this quantity squared. So when I'm ever solving a problem and I see this quantity squared, I'm going to solve using square roots. Here's our problem. Negative 2 times x plus 2 squared equals negative 16. So go ahead and copy this down. Now we had a parenthesis in example 1, but I want to point this out to you. In example 1, the x squared was inside of the parenthesis, so I started by distributing the 3. Now here, the quantity is being squared, okay? And so in that case, we are not allowed to start by distributing the negative 2 because you would do your exponents first. So what we're going to do to get started is let's divide both sides by negative 2, and we get x plus 2 squared is equal to positive 8. The temptation is going to be to expand out the x plus 2 and the x plus 2, and I'm going to tell you right now, don't do it, okay? You're going to make the problem harder. You're not going to be able to solve it. You're going to get stuck. Instead, we're going to undo the squared by square rooting both sides. And the square and the square root cancel, and now we have x plus 2 equals. Soon as we square root, it's plus or minus the square root of 8, okay? Can we, in our next step, go ahead and simplify the square root of 8? And I'm going to split this into square root of 4 and square root of 2. And this is going to be plus or minus 2 square root of 2, right? Now finally, we're going to subtract 2 from both sides, which then kind of brings up the question of where do we put the negative 2? Well, the negative 2 is going to go out in front of the plus or minus. And this right here is going to be the exact answer. Just as a quick little note, I'm going to do this over here in green. You can, if you want, you can put the negative 2 behind it. It just looks funny, okay? So what we typically do is we put it out front and put the plus or minus in the middle. Now I'm going to go into the calculator here, and I want to kind of talk about what that solution looks like. Well, what that means is we can take negative 2 plus 2 square root of 2. So the first, I think I wrote that wrong, negative 2 plus 2 square root of 2. So the first approximate solution is 0.2828, okay? And the other solution is negative 2 minus 2 square root of 2, and the second approximate. And so what you're looking at right here is the approximate decimals for where the parabola crosses the x-axis. They're useful in some situations, but like we said, often the exact solution is going to end up being more proper, in some instances more useful. All right, I have more examples that we need to go over before we get to the homework. So I'm just going to kind of treat these kind of like on your own. And we're going to work through 3 problems. And so what I'm going to have you do is I'm going to have you, once you copy these down, I want you to hit the pause key, and I want you to go ahead and get started on these. And you're probably going to get stuck at a certain point. So write these down. Do anything you can, okay? Do as much work as you can, but be prepared that you're going to get to a point where they just look a little different than the 2 examples we talked about. And so then what you're going to do is go back over the video and watch me finish the problems and kind of fill in the gaps and see what part you were missing, okay? So go ahead and hit pause and do as much as you can on these. All right, let's work through these and see how to get our answers. So in this case, this is like example 1 where we just have an x squared. So let's go ahead and get the x squared by itself. And I'm going to divide both sides by 5. Now this time, what I see is I have x squared equals 3/5. And we're going to square root both sides, okay? And we're going to end up with, I'm going to swing up here, x equals plus or minus the square root of 3/5. You're not going to find this in an answer key. You're not going to find this on the answered scrambled. It's just not considered simplified. And so what we're going to do is we're going to split the radical, okay, as the square root of 3 and the square root of 5, and we're going to rationalize it by multiplying the numerator and the denominator by the square root of 5. And so our answer is going to be plus or minus square root of 3 times square root of 5 is square root of 15, and then square root of 5 times square root of 5 is going to put a whole number 5 in the denominator. And that is going to be the simplified exact solution. All right? So even if it doesn't say in the directions, we're always now making an assumption that we're going to rationalize the denominator and we're going to simplify our radicals. Let's see what's going on here with number 2. Because of this quantity squared, right, you are not allowed to distribute the 3. And so let's go ahead and divide it. And we get 2x minus 1 is equal to 9. Oops, 2x minus 1 squared. This is the part where I'm going to square root both sides because I want to cancel out the squared. So 2x minus 1 equals plus or minus 3. That plus or minus is what we're going to put not at the end of the problem, but as soon as we're at that step where we square root both sides. All right, let's keep going. Let's add 1 to both sides. And so this is going to be, you know what, I'm going to swing right up here with my work because I'm running out of room. 2x equals 1 plus or minus 3, right? Because we added it over. And then we're going to divide by 2, and we get 1 plus or minus 3 divided by 2. Now, if there was a radical, I would leave the answer like that. It's simplified, but there's not. And so since we have all whole numbers, we can further simplify by splitting this, okay, into 1 plus 3 divided by 2, and we can split this into 1 minus 3 divided by 2. Well, 1 plus 3 divided by 2 is 4 divided by 2. 1 minus 3 is negative 2. So our roots are 2 and negative 1. And so I just think it's important to note that first off, you don't always have a radical just because you solve using square roots. And second, when we have these fraction type problems, we have to kind of decipher when can we simplify more and when do we leave it, okay? So last example, this one looks pretty simple at first glance. We're gonna go into it and we're gonna minus 12 from both sides, and we get that x squared equals negative 8. Well, when we go to square root both sides, do you remember what happens when you square root a negative? Well, when you go ahead and grab your calculator and type in the square root of negative 8, and what should happen is you are going to get an error, okay? And I want you to remember that you are not going to get a real number when you square root that negative. You're going to get a different type of number that we're going to talk about later. So for now, all you need to know, okay, is that we're going to write no real solutions. And what we are solving here is one of those parabolas that do not cross the x-axis. Until we learn more about quadratics, we can't really get that solution right now. So we're for now just going to write no real solutions. Okay, well, we did a ton of examples. I hope that helps. And thanks for listening. See you next time.